everything is working, okay? So chapter 2 is working with real numbers, and a lot of it from 2.1 to pretty much 2.5 is properties and adding, subtracting numbers, multiplying numbers, subtracting numbers. So I'm kind of putting all of 2.1 to 2.5 in today's lesson, okay? It is not that long because there are some things that are in your book that I'm not covering here because I think you guys should know if I give you 2 plus 3, you should be able to add 2 plus 3, right? Okay. Hopefully. Okay. All right. So let's talk about some properties, okay? Addition and subtraction is closed under all these properties, okay? A plus B and A times B are both unique real numbers. And the reason for that is because if I add any type of number, any real number, or multiply any real number, I will always, always, always get another real number, right? If I take any decimal plus any decimal, I'm still going to get a decimal, and it's going to be a real number, right? Yeah, you guys haven't learned about anything that is not real, okay? So adding and subtracting, or adding and multiplying are closed under these properties. Okay, so the first property we're going to talk about is the commutative property, okay? The commutative property says, if I have, and there's commutative property of addition and multiplication, but the commutative one, if I take A plus B, that is going to be the same thing as B plus A, okay? And that should make sense, right? If I take 2 plus 3, it is the same thing as 3 plus 2, right? Yes, okay. And it's also true with multiplication. If I take A times B, that is going to be the same thing as B times A, okay? So any two numbers can be added or multiplied in any order. Can I subtract numbers in any order? No, only if I change the subtraction to what? Addition, okay? And then same thing with division. Division is not unless I turn it to multiplication by its reciprocal, okay? The next property is your associative property, okay? The associative property says if I take A plus B, add that first, and then add C, is going to be the same thing as if I add B plus C first, and then add my A. So it's just taking any three numbers and adding it in any order, and it's still going to be the same, okay? Same thing with multiplication. A times B, then times C is going to be the same thing as B times C, then times A. And I just moved the parentheses in this sense instead of switching the order. But the parentheses says I would have to do it first, right? Okay. All right, your properties of equality, there are 3 of them, okay? You'll see a lot of these in geometry next year. So this would be good to memorize these ones too, okay? The reflexive property says if A will equal A, 2 equals 2, 3 equals 3, right? It's a reflective property. You look in the mirror, you're going to see your reflection. It's the exact same thing, right? Okay. The symmetric property says if A equals B, then B will equal A, right? If 3 equals 2 plus 1, then 2 plus 1 is going to equal 3, right? That should make sense to you guys, right? So the symmetric is saying that they're symmetric on both sides, okay? All right. And then the last one is our transitive, okay? If A equals B and B equals C, then A will equal what? C. Okay, so if A equals B and B equals C, then automatically A is going to equal C. Okay, make sense? Okay. A little, kind of, but we got equal signs here, yeah. Multiple things there. All right, so now this one we're just going, yes, we are adding or multiplying, but we're going to simplify these using the commutative and the associative properties. Okay, so we're going to switch the orders to make it easier for us, right? Okay, because if I look at like 43 plus 78 plus 7, I'm not going to want to take 43 plus 78 right away, would you? No, what would probably be the easiest to add together first? The 7 plus 43. And I like those two to add first because that gets us to end in what? A 0. So I get 50 there. Now add 78. That makes it a lot easier, doesn't it? So now what is 50 plus 78? 128. That's a 2, by the way, guys. Okay. All right, number 2. I'm going to go down here. Number 2, 5 times 83 times 2. So normally I'd go in order, 5 times 83. But that, I really don't want to do 5 times 83, would you? No, but I could take 5 and multiply it with what? 2. And then times it by 83. Because what is 5 times 2? 10. And anything times 10, all you have to do is add a 0. So we get 830. Okay. So by us doing, switching the order and multiplying and adding things in different order, we're using these properties. We don't necessarily always have to state them unless they tell us to. Okay. Now, number 3. Okay. 3x times 2y. Okay. Now with this, when we see 3x, what does 3x represent? 3 times x. Times, what does 2y represent? 2 times y. So this is all multiplication. So does it matter the order we multiply? No. So what I'm going to multiply is I'm going to multiply a 3 and a 2. So 3 times 2 is 6. And I can't multiply x or y. So I just leave it as 6xy. Right. Okay. So we're going to leave it. We don't want to write it as 6 times x times y. We always get rid of those times symbols and just put it as 6xy. Okay. Now, number 4, okay, we'll talk about the letters here in a second, but what can be combined in number 4? The 1 and the 2, they're both numbers, right? So what is 1 plus 2? 3. So we have 3. We have a plus a and a plus b. Now, we'll learn here in a few minutes, we can't add these because these are known as unlike terms. And we don't want to put these as 3ab because 3ab represents 3 times a times b, okay? All right. Now, so we've applied those properties. Now we're actually going to identify the properties, okay? No, on Monday, you're going to have a quiz over this lesson. So we will be going, you'll have to know these properties, okay? Name the property illustrated. So we're taking 3 times 14 equals 14 times 3. So we have 2 numbers and we're just switching the order. So is it commutative, associative, or the properties of equality? What allows us to take 2 numbers and switch the order? Okay. No? No, this would be the commutative property. Okay. It's the commutative property of what? Multiplication, okay? Someone here said that, he said the symmetric, right? Remember, symmetric is if A equals B, then B will equal A, right? They'll use the words if and then, okay? Here, we're just switching the order that we multiply. Yeah. Yeah, okay? Now, yes, like number 2. So since we're using the if and the then, this is where we're going to use one of those properties of equality, okay? Now let's look at, let's do 2. If 7m equals 35, then 35 equals 7m. This one is symmetric, yeah. It's not reflective because reflective is if 7m would equal 7m. It's the exact same. Transitive, if A equals B and B equals C, then A would equal C, okay? Okay, and then number 3, okay, we have 2 plus 3, okay, we're adding 2 plus 3 first, then adding 5. In the second side there, we're adding 3 plus 2, then adding 5, okay? So off our bat, we're gonna be, because we're talking about addition here, we're looking at the commutative or the associative, right? Now, remember, the commutative property takes two numbers and we add them in any order, right? Associative takes three numbers and switches the order of all three of them, correct? Now, if I look at the parenthesis, I'm taking 2 plus 3 the first time. The second time, I'm just taking 3 plus 2. So am I adding the same two numbers first? Yes, I am. So I'm only switching the order of how many numbers? 2 of them. Then we're adding 5 last. So because we're only switching 2 of the numbers, this again is the commutative property of what? Of addition. Of addition, okay? Now that's where it gets tricky because yes, there are 3 numbers and they still have the parentheses, but we're still, the last step we do is add 5 for both sides, right? We're only switching the inside of those parentheses and inside is only 2 of those numbers, okay? And then number 4 here, 3, we're taking 2 times x, then timesing 3, so 2x is what we're doing first, equals 3 times 2, so we're going to multiply 3 times 2 first, then times x. So in this one, is this one the commutative or the associative? This one is our associative because we're switching the order of the first 2, right, the parentheses there, okay? All right, so now let's add in a couple more properties, okay? Identity, okay? When you think of identity, I think of ID, I think of yourself, right? Okay, so if I'm looking at addition, the identity of addition says if I take a number and add it to something, I'm going to get back to its identity itself. So if I take a number plus what gets me back to itself? 0. Okay, so the identity of addition is taking a number plus 0, getting back to the original problem. Okay, for multiplication, we're taking A, multiplying it by something to get back to its ID, its identity, and that would be our 1. So if I multiply by 1, that would be the identity property of multiplication, okay? All right, inverse property, okay? The inverse for addition is kind of the opposite of the identity, okay? So the identity plus 0, okay, gets back to its identity. So now we're looking at A plus what now gets us to 0. Okay, so let people think for a second. So A plus what would get me back to 0, okay? So we're going to add its opposite, right? We talked about opposites before. So if I take any number plus its opposite, we will get back to 0. That would be the inverse, okay? That's a negative A if you can't read it, okay? Now for multiplication, okay? A times what would get me to, now the opposite of identity. Identity was multiplying by 1, so we're going to get to 1. So A times what gets me to 1? Okay. Well, let's think of a number. Okay, let's throw in the number 2. 2 times what would get me to 1? Okay, let's think of this multiplication. 1.5, not 1.5, a half, right? Which is 0.5, but we're going to keep it as a fraction, okay? Think about this because normally we'd say, well, 2 divided by 2 is 1, right? Well, we don't want dividing, right? We want multiplication. So dividing by 2 is the same thing as multiplying by what? 1/2, right? Okay, we'll talk about that later. All right, 3 times what would get me to 1? 1/3. So it'd be 1 over A. Now, if I had like 2/3, 2/3 times what gets me to 1? Nope. 3 over 2, the 1.5. Why? Because the 2's will cancel, the 3's will cancel, and I'm just left with 1, right? When you flip the fraction, do you know what that's called? When it's the flip of the fraction? Reciprocal. Shh, guys, come on, boys. Okay, so A times 1 over A equals 1. So it's the reciprocal. Okay, so there's a couple more properties that will be added in. Okay, now let's look at some vocab. Okay, all right, a term. A term can be a number. Okay, a term can be a number. So is 5 a term? Yeah, it's a number. Okay, it can be a variable. So would X be a term? Yeah, X is a variable, isn't it? Yeah. Could it be Y? Yeah, okay. Or it could be the product, and product means multiply, of a number and or variables. So could 2X be a term? Yeah. Could 3XY? Yeah. Could 9X squared? Yes, because X squared just means X times X. Could 9X squared Y? Yes. Could 7X squared plus 2 be a term? No. No. We got a plus sign. Okay. Now, we can look at 7X squared is a term. 2 is a term. So in this 7X squared plus 2, there are actually 2 terms. Okay. That plus sign or subtraction sign actually separates the number of terms. Okay. A term is another word for monomial. Okay, if you've heard monomials before. Okay. Now, the coefficient is the number being multiplied by a variable. Okay, I will use this word a lot to make sure you know it. So if I say 2x, what is the number being multiplied by the variable? 2. So the coefficient is 2. Okay. If I have 9x squared, what's my coefficient? 9. If it was negative 9x squared, negative 9. Okay. If it was y, what's my coefficient? 1. Mary? Okay, thank you. I know they're a little more loud. Thank you. Okay. So coefficient, if you have a single y, it's always 1. If you have a negative y, it would be a negative 1. Okay. All right, a constant is a number without a variable. So it's a number without a variable. So like 2, 7, those are constants. They stay the same, okay? When we see like 2x, that 2x could change if I put a value in for x. 2 and 7 would never change because there's no x being multiplied to it, okay?
Pi is also an example.
Yep, pi is too, okay? Yep. All right, like terms, okay? Like terms will have the same variable and exponent. Same variable and same exponent. Okay, same variable and same exponent. Okay. So like 2x and 3x. Those would be like terms because they have the same variable of x and their exponents are the same, okay, which is 1 in this case. 9x squared and 3x squared, or negative 9x squared and 3x squared. Those are like terms because they have the same variable of x and the exponent of 2. Okay. Would 9x and 7y be like terms? Nope. Would 3x squared y and 4xy squared? No. And the reason being is because we have 2 x's here and only 1 x here, okay? 2 y's in the other one, 1 y in this one, okay? All right. Now, why do we need to know like terms? Because the only way you can combine things with variables is if they are alike, okay? So adding and subtracting like terms. Okay. To add and subtract like terms. Again, they must be like. If they're not like, you can't add or subtract them. Okay. You're going to add or subtract the coefficients. So the numbers in front, you're going to add or subtract them. Huh? All right, then once I add and subtract the coefficients, we're going to keep the variable and the exponent the same. They will not change whatsoever. So example 3 here, okay, simplify the expression, okay? So we have 2x plus 5x. Are these like terms? Yes. So if they're like terms, what we're going to do is we're going to add or subtract the coefficients. So 2 and 5. So what is 2 plus 5? 7. And we're going to leave the variable the same. So it's just going to stay 7x. Okay. I kind of think of it this too. A lot of people want to see if I have x squared and x squared, they want to make it x to the 4th. I always think about adding and subtracting in like fruit. If I have 2 apples plus 5 apples, when I add them, I have 7 apples. They don't become oranges, do they? They do not. So that's why your variable is always going to stay the same in your exponent, okay? All right, number 2, 7x minus 5 plus 2x plus 9, okay? Please. Okay, now, when we look at this, let's go ahead and find my like terms, okay? So 7x is alike with what? 2x, and we always follow the sign that is directly in front of the like term. Don't follow the other signs, the one directly in front. So 7x plus 2x. So 7 plus 2 is 9, and we leave the x alone, okay? Now, the next like terms. We have a negative 5 because it's a minus 5, so that means it's negative, and we have a positive 9. So a negative 5 plus 9 is a positive 4. Since it's a positive 4, I'm going to put plus 4. Now, can I add 9x and 4? No, they are not like terms, so I'm going to leave it as 9x plus 4. Okay, and that is your final answer. Okay. All right. Number 3. Okay. Let's start with negative 2x. Is negative 2x alike with anything? 3x, and what sign's in front of the 3x? A positive, right? So what's a negative 2 plus 3? 1x. Now, I don't like 1x because 1x actually represents what? Just x. So we always simplify 1x to be x, all right? All right, now, those are done. We have a negative 4x squared. Can that be combined with anything? Negative 3x squared, because we always follow the sign in front. So we have a negative 4x squared and a negative 3x squared. Because both of these are negative, can I just add them? Yep. So what's a negative 4 plus negative 3? Negative 7. So since it's negative, I'm going to put a minus sign. And does my variable stay the same or do they change? Stay the same, so it stays x squared. And then do I have anything left over? A 2, but what is 2?
Negative.
Negative, so I have to put minus 2. Now, we can't combine anything else, so we're actually done. Does anyone know standard form?
It's the one, like, negative 7x squared, negative 7x squared, that's our.
Okay, so standard form is actually like highest exponent down to the lowest, okay? So we're gonna kind of start writing this. So if you have this, this is correct right now, but then I always want you to kind of show this, but then try to go from highest exponent down to the lowest exponent, okay? Because that will help you out later on, okay, when we actually have to do that. All right, so that's combining like terms. Now we're gonna add in combining like terms with the distributive property, okay? Now, the reason we have the distributive property is to help us with those parentheses, because sometimes inside the parentheses, we can't combine like terms, okay? Because orders of operations say you do the parentheses first. If I can't add inside the parentheses, to remove them, we use this distributive property, okay? And the distributive property says, if I have a number on the outside, so like A times B plus C, okay? I can't add B plus C because they're not like terms, they're different variables. So to remove those parentheses, I take this outside number and I multiply it to everything on the inside. So I'm gonna take A times B, which is just AB. You can always multiply unlike terms, you just can't add and subtract. And then A times a positive C becomes a positive A times C, okay? Always, always, always watch those signs, okay? Right, but can I actually do what's inside the parentheses? No, because they're not like terms. So then we distribute, yep. Yep. So now if it's minus, it's the same idea. We're gonna take A times B, but now when we multiply, A times a negative C is going to be a negative number, so I put a minus AC, okay? So again, the only time we honestly use the distributive properties if we cannot combine like terms inside the parentheses, okay? So as I look at example 4 here, number 1, if I go to do what's inside the parenthesis, can I add x plus 5? Right, I could if I knew what x is, but I don't. So we can't add that. So the only way we can remove it is by taking this outside number 2 and multiplying it by everything on the inside. So I'm gonna take 2 times that x, and then I'm gonna take 2 times that positive 5, okay? So what's 2 times x? 2x, and 2 times 5 is a positive 10, so I put plus 10. Now, can I combine 2x and 10? No, because if I can't combine the parentheses, I won't be able to combine after I distribute. So that would be right there your final answer. So here's your final answer. Okay. Don't combine those. All right, number 2, can I do what's inside my parentheses? 3x minus 4. Nope. Okay, we're not going to keep doing that, okay? We obviously don't know what x is, okay? And remove it. -1 times 3x is what? Negative 3x. Then we're going to take that -1 and times it by what? Nope. It's a minus. That's a -4. So, okay. So that's a -4. So 2 negatives make a positive. So we have plus 4. Yes. All right, number 3. Okay, we can't do what's inside the parenthesis. So in that first parenthesis, we're going to distribute the 2. And then the second one, we have a plus 5. So that means we're going to distribute a positive 5. Always use that sign in front of it. Okay. So 2 times 3x would be 6x. A 2 times 8 would be 16. And I'm going to multiply the positive 5. So positive 5 times 6x, a positive 30x. And then a positive 5 times this -4, because that's minus, means it's negative, is a -20. Now, as I look at that line there, we do have like terms. So we're going to go ahead and combine those, okay? So as I look, 6x can be combined with a positive 30x, which gives me what? 36x. We have a positive 16 and a -20. So a positive 16 minus 20 would be a -4, so I put -4. Okay. Now, we don't have any more like terms. That is my final answer. Okay. All right. S3. Okay. All right, looking at number 4 here. Okay, again, we can't do parentheses because we have x's and constants in there. Okay, so the first one, I'm going to distribute a 3, and the second one, it's a -2, so I have to distribute a -2. Okay, make sure you treat that as a negative. Okay, so 3 times 3x is 9x. 3 times, now it's a minus 4, so that means it's a negative 4. So 3 times a negative 4 is a negative 12. Now, again, negative 2. So a negative 2 times a positive 2x is a negative 4x. And a negative 2 times a negative 5. Two negatives make a positive, and then 10. Now we're going to go ahead and combine like terms. 9x is alike with this minus 4x. So 9x minus 4x is 5x. Okay. We have a minus 12, so that means it's negative, and we have a plus 10, so that's positive. So negative 12 plus 10 would be a negative 2. We do not have like terms, so we are finished there. Okay. All right, number 5. Okay, we can't do what's inside the parentheses. So in the first one, I'm going to distribute a negative 3. And then the second one, we just have a minus sign in between it. So that means I'm distributing a negative 1. Okay. So a negative 3 times 2x is a negative 6x. A negative 3 times a positive 9 is a negative 27. Now we're going to distribute this negative 1. A negative 1 times 6x is negative 6x. And a negative 1 times a negative 5. Two negatives make a positive 5. Okay. So now let's combine like terms. Negative 6x and negative 6x. They're both negative, so I'm going to add those numbers. So negative 6 plus negative 6 is 12x. Negative 27 and a positive 5. Those signs are different, so we're going to subtract them. So 27 minus 5 is 22. And is it going to be positive or negative? Negative, so I put a minus sign. Now negative 12x minus 22 are not like terms, so you are finished. All right, and then our last one here, number 6. Okay. Now I threw in 3 parentheses, but that doesn't change anything. We're just going to have more like terms after we distribute. Okay. So the first parenthesis I'm going to distribute a 2. The second one's plus 4, so I'll distribute a positive 4. And then we have a minus 2 for that third one, so it's a negative 2 we're going to distribute. Okay. So 2 times 3x gives me 6x. 2 times a negative 4, because it's minus 4, is a negative 8. Okay. A positive 4 times x is a positive 4x. A positive 4 times negative 6, because it was minus 6, is a negative 24. Now we're going to do a negative 2. A negative 2 times 6x is negative 12x. And a negative 2 times a positive 4 is a negative 8. Okay. So now let's combine like terms. 6x, 4x, and negative 12x. So 6 plus 4 is 10. 10 minus 12 is negative 2x. Okay. Now we have a negative 8, a negative 24, and a negative 8. So negative 8 and a negative 24 is negative 32, and a negative 32 and a negative 8 is a negative 40. Okay. Now, can I combine negative 2x and negative 40? Nope. So this here would be your final answer. Okay. So that actually pretty much covers everything on this lesson here. Okay. I'm going to go ahead and stop